All right, before we get started, are there any questions? Yes.
If the df is 39 on the t table,
Oh.
you use 30 or 40?
Okay, yes, so this is a good question. So the T table does not have every single DF listed, okay? So, so if your DF is not listed in the T table, okay, always round down. Yeah, so for example, let's say your n is equal to 40, then your DF will be 39, and 39 is not in the table, so use round down. And use 30 DF in the table. Okay. Good. Any other questions? Oh, we're good? Okay. All right, well, I thought today I would spend some time just in review. I was not going to review the practice final unless there are specific questions from the practice final. So that's been posted, the answers have been posted, and I'm hoping it has served as a useful practice for you guys. I think the practice final is good for going over kind of the calculation-based questions, and then there will be some conceptual questions from chapters 7, 8, 9, and then some conceptual questions from chapters 1 through 6. So I was thinking of spending today going over some of those conceptual topics. But again, if you have any questions on anything, whether it be conceptual or calculation-based, I'm happy to answer those questions. I will have office hours today from 2 to 4 p.m., so if you have other concerns, you can come visit me during office hours. Today's office hours from 2 to 4 will be shared with my other class, which is the kind of the statistical programming class, so you might see other students there as well. Okay, so let's get into this review. Okay, so maybe just a course overview. We had a few sections. We had descriptive statistics, and these were kind of chapters 1 through 4. And then we learned probability, chapter 5, probability distributions, specifically the normal distribution, which was chapter 6. And then we learned sampling distributions. Chapter 7, okay? And then the sampling distributions came together with our understanding of descriptive statistics, and we had a section on inferential statistics. Okay, and as far as this class got, for inferential statistics, we learned confidence intervals for P, hypothesis tests for P, hypothesis tests for P1 and P2. And we learned confidence intervals for mu and hypothesis tests for mu. We didn't get to cover the two samples and numeric variables for means. Okay. So far, so good? Okay, and so most of our inferential statistics deal with one sample at a time. We did learn two samples, and for this class we only dealt with two samples proportions, okay? And so there were some questions in the practice final that dealt with two samples and proportions. The other ones that dealt with two samples and means, I think I instructed you guys to skip those problems. Okay. Did the practice final go okay for you guys, or are there questions, concerns? Have we not looked at it yet? Some of you guys, I know, well, some of you guys are nodding and smiling, so I'm hoping that's a good sign. Okay, well, all right, well, let's talk about conceptual topics for inferential statistics, okay? Okay, so one will be checking conditions. Okay, so technically, every time you perform inferential statistics, you should check conditions. Now, it's hard to write an exam where you're supposed to check conditions, and if the conditions aren't met, you're supposed to stop, okay? Because I feel like I'd be writing, I don't know, some kind of trap questions or something where it's like, you know, figure out the p-value, but haha, it was a trick because the conditions weren't met or something. So so what I'm going to have is on the exam there will be maybe like 4 questions that are just for checking conditions, okay? And then all of the other problems are you don't have to check the conditions. And I think this is how it was set up in the practice final as well, okay? Where you just have a few questions for the designated for the topic of checking conditions, and then all of the other problems you can assume the conditions are met. You don't have to waste time checking conditions for all of the other problems, if that makes sense, okay? So these ones that check conditions, there are 3 conditions you need to check. One is the random and independent condition. You need to make sure that you have the large sample condition, that this is met, and you have the big population condition. Okay. So I'll say a few problems designated and then all other inference questions Okay, and a lot of times students get the large sample and big population condition met. Okay, so basically large sample condition, the sample needs to be big enough. And then the big population condition is the sample cannot be too big. So the sample needs to be just right. You can't have it too small, but it can't be too big. Okay? So the large sample condition, and so the way we check the large sample condition so either at least 10 successes and at least 10 failures. Okay. Or if the counts are not given, n times p must be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. Okay. So sometimes you're not given the number of successes and number of failures, but you're given you know, what population proportion you have. Okay, and then the big population condition the population needs to be at least 10 times bigger than the sample. Okay. And I had, there were some questions on the practice final on this stuff. Were there any concerns about that? Or did we feel okay? Okay. I guess that's that. Okay. All right. Well, so let's talk about stuff from inference. Okay. So maybe we'll talk about hypothesis tests. Okay. So first off, you should know what the definition of the p-value is. Okay. So how can we define what a p-value? Okay, well, I'll tell you then. The p-value is the probability of observing our data or something more extreme if what? If we assume that the null hypothesis is true. Are we doing okay? You guys are awfully quiet this morning. Just want to make sure. All right. I hope you've enjoyed the class as much as you can, right? As far as taking a compressed stats class in the summer goes, I hope it's been good. I've enjoyed it, but of course that's me, right? This is my dream job, for real. Student evaluations, that's open, so please leave a review. I hope you like the class. Give me all super high marks, and that'll help me out. And because once I file the grades, the window closes. So get your reviews in, please. And your comments are always helpful. I read through all of them, and I try to take those into account as for future classes. Of course, by this time it's too late for you guys, but I hope it's been good. Okay, so this is our p-value. Okay, so let's let's talk about what does it mean to get what does it mean to get a certain p-value, right? So let's say we do a hypothesis test. Oh, and here's the thing. When we talk about p-values, it only appears for hypothesis tests. There's no p-values for confidence intervals, okay? So let's say we do a hypothesis test for, and we have the null hypothesis, mu is equal to 56, and then the alternative is that mu is greater than 56, okay? All right, and so let's say your data has, if we're dealing with mu, our data is going to have what values? What summary stats will we use for our data if our null hypothesis has a mu? We'll be dealing with x bar, right? So let's say your data has x bar equal to 61, okay? All right, and you do your calculations, and from the calculations you get your p-value. If it's a hypothesis test for mu, your p-value is going to end up between some values, right? So let's say your p-value ends up between 0.2 and 0.1. Okay, what does it mean that our p-value is between 0.1 and 0.2? Okay, here, let's try a few answers out. Okay. Answer choice A, the probability that the null hypothesis is false is between 0.1 and 0.2. Part B is the probability that the null hypothesis is true .1 and 0.2. Okay, are either of these correct? Yes, no? Is one right, wrong, one wrong? Okay, both of these are wrong, okay? These are not, it's not the probability of the null or the alternative or whatever it is, okay? It's the probability of observing our data. So the correct answer would be If the population truly has a mean of 56, okay, if the population truly has mu equal to 56, then the probability that a random sample has x bar equal to 61 or more, that probability is between 0.1 and 0.2. It's the probability of getting our data, or something more extreme, if the null hypothesis were true. So if the null hypothesis, meaning if the population truly has mu equal to 56, then yes, from random chance, we can get random samples where the mean is 61 or more or something. And what's the probability of that happening? That has a probability between 0.1 and 0.2. Sounds good? Okay. All right. Let's try another one. Let's say your null hypothesis is that P is equal to 70%. And your alternative is that P does not equal 70%. And let's say your P value is equal to 0.15, I don't know, 88, okay? I'm just making this up. What does this mean? Here's some answer choices. Which is correct? We have evidence that mu is true. Or we have evidence that the alternative is true. Or we do not have evidence that mu is false. I don't know, is there something else I can write? Yeah, we'll just leave it at that. Okay, what do you guys think? So the correct answer is, so our p-value, okay, so let's assume alpha is equal to 0.05. Our p-value is greater than alpha, so that means we do not reject the null hypothesis, okay? We would never, we never say that the null is true, okay? And then we never say that the alternative is false, okay? We never phrase them. So it comes down to this and this, and the correct answer choice is C, because we are not rejecting the null. So we would say we don't have evidence that the null is false. Other things we can say is we do not have evidence to support the alternative. That's fine, okay? or we can say we do not have evidence it's all right, also correct. Do not have evidence that the proportion is different from 0.7. Any questions on this? Or is this all, are we all good here also? Or not so good? Okay. All right, let's try this, okay? So let's say you do a hypothesis test with alpha equal to 0.05, okay? And let's say at the end of the test, you conclude, I have evidence that the population proportion is greater than 0.5. Okay? So let's say you've done this, okay? All right. Let's say someone else uses the exact same data. Exact same data. And with the same exact same data, and does another hypothesis test with the same hypotheses. I mean, this someone else could be you again, but this time they use alpha equal to 0.10. What conclusion will be made? Okay, so I didn't provide any data. I just said you've done a hypothesis test with alpha equal to 0.05, and at the end of that hypothesis test, you come to the conclusion, I have evidence that the population proportion is greater than 0.5. Okay, if you use the same data, same hypotheses, did this test again, and the only difference this time is that alpha is 0.1 rather than 0.05, what happens to your conclusion? Does this question make sense? No? Yes? So, okay, so all right, so let's back up. Okay, when we did the hypothesis, so basically it's just I'm giving you the same assignment. I'm saying redo the exact same hypothesis test, same data, same everything. Okay. The only thing now is instead of alpha being 0.05, you're going to use alpha equal to 0.1. Okay? What's this going to affect? Yeah. Yeah, it will be the same conclusion, but let's just back up. So when you use the same data and the same hypotheses, what's going to happen to your p-value? Nothing. Okay? Same data, same hypotheses. Your p-value will remain the same. Okay? Same data, same hypotheses. The p-value will remain the same. Right? Okay. Do we know what our p-value is? We don't know exactly what it is, but we do know a few things about it, right? We came to the conclusion that I have evidence that the population proportion is greater than 0.5. Okay? So what is my p-value then? So this language means I have chosen to reject or not reject the null. It means we have chosen to reject the null hypothesis. Do we see that? Okay, because we're saying I have evidence for this thing. So we've rejected the null. So if we've rejected the null, that means whatever our p-value was, our p-value was less than 0.05. Is that okay? So I've chosen to reject the null, and so that means my p-value is less than 0.05. Okay, so my p-value is going to remain the same. So this time I'm going to use alpha equal to 0.10. Okay, so I don't know exactly what my p-value is. I do not know the exact p-value, but we do know our p-value is less than 0.05. Okay, so if I used alpha, equal to 0.10, is my p-value less than alpha? Yes. Okay, we know our p-value is less than alpha. So we will reject the null hypothesis still. Okay. Does that make sense? What if this time I used alpha equal to 0.01? Okay. Let's say redo the test. Use alpha equal to 0.01. Okay, what conclusion will I make? And the answer here is we don't know. Unless we get the exact actual p-value, we don't know. Okay, we do not know because we do not know if the p-value, all we know is that the p-value is less than 0.05. We don't know if the p-value is going to be greater or less than 0.01. Yes, question. This could have just been any number. This is an arbitrary number. All this says is that from this statement, what do we know my null and alternative hypotheses are? I know my null hypothesis is that p is equal to 0.5, and then my alternative would be what? P is greater 0.5. Okay? From from this conclusion statement, we know that this is what our null and our alternative hypotheses are. Does that make sense? Okay, so I could have put in 0.6 or 0.7 or whatever. This 0.5 has nothing to do with this 0.05. Okay, the 0.05 is just our choice of alpha. This is the value that we're using in our hypotheses. Yeah, question.
So we would kind of do the same thing if we wrote greater, less than, or not equal to 0.5, right?
Exactly. Okay.
But if we were equal, then we would assume that we didn't reject the null, and we would do this a little different.
I'm sorry. We would never say I have evidence that the population proportion is equal to 0.5. We would never say that. We could say, I have evidence that the population proportion is greater than 0.5 or less than 0.5 or different from 0.5 or not equal to 0.5.
If you reject, right? This implies we reject.
If we rejected, yeah. The other possible conclusion is I do not have evidence that the population proportion is greater than 0.5, or I do not have evidence, whatever. And in that case, what that implies is that we did not reject the null, and that means the p-value was greater than 0.05. Okay, and you would use that base of knowledge to go from there. Is that okay? All right, let's maybe just a couple definitions here. Alpha is our significance level, and this is equal to the probability of what error? And we have beta. This is equal to the probability of what type of error? Okay, so beta is type 2, and alpha is type 1. Okay, all right, so let's define what is type 1 error. Type 1 error is our false positive, and what does that mean? The truth is what, and what did we conclude? In type 1 error, the truth is what? The null is true, and we've concluded to reject the null. So that's type 1 error. So this would be convicting a guilty person, right? Convicting a guilty person, or the other example I did was thinking a healthy person is ill. I'm sorry, convicting an innocent person, not guilty. Convicting a guilty person, that's what we want to do. Convicting an innocent person, or thinking a healthy person is sick. Okay. Type 2 error. What is type 2 error? False negative. And here the truth is the null hypothesis is false, and our conclusion is do not reject the null. Okay, and this would be acquitting, I don't know if that's the right word, okay, acquitting a guilty person. Okay, or thinking a sick person is healthy. Oh, right, I should actually write sick person is not sick. Okay. Okay, and so if type 1, so depending on the context, if type 1 is worse than type 2, we want large or small alpha. If type 1 is worse than type 2, we want small alpha, okay? And on the other hand, if type 2 is worse than type 1 error, we want large or small alpha. We want large alpha. Okay. So I might list off a scenario. So over here, we have convicting an innocent person versus acquitting a guilty person. And in that case, the type 1 error is worse. And in the other one, we have thinking a healthy person is sick versus thinking a sick person is not sick. We have a different, type 2 is worse in that case. Okay. So I'll list off a scenario, okay, and you'll have to decide whether type 1 or type 2 is worse. I think in certain situations it'll be like, well, maybe it's subjective, but I think in the scenario I've listed in the exam, it will be quite objectively clear which error is worse than the other. Type 1 or type 2 is worse than the other, and then you'll decide if we want large or small alpha based on that. Is this okay? All right, why don't we take a short break here, and then we'll come back. We'll keep talking about all of this conceptual stuff.